So in this question it says if an unbiased die is thrown 1,000 times, the total score will be approximately what? Firstly, an unbiased die means that it is not biased. Secondly, what does bias mean? Bias means unfair. Something is biased, then it's unfair. So if it's not biased, then it's not unfair, which means that it's fair. Okay. An unbiased die is thrown, something wrong with the die, 1,000 times, and the total score will be approximately what? Firstly, if you have a dice, how many sides does the dice have? A dice will have a total of 6 sides. So therefore, it says here, if an unbiased die is thrown 1,000 times, the total score will be approximately what? How are we supposed to figure this out? The outcomes on a die can be 1, 2, 3, 4, 5, or 6. What we need to do is we need to find what's the probability of getting 1, or 2, or 3, or 4, or 5, or 6. And from there, once we found the proportion, then multiply it by 1,000 as an expected value. Now, if an unbiased die is thrown 1,000 times, the total score will be approximately what? Now that is quite hypothetical because approximately you could get any one of those values. Let's suppose you got, for example, 1 1,000 times. If you go 1 1,000 times, then your total score will be 1,000, for example. All right, but there's a probability of that, right? The probability of getting 1 is 1 out of 6. And the probability of getting 2 is also 1 out of 6, etc., until the probability of 6, which is also 1 out of 6. If it's thrown 1,000 times, then approximately is pretty vague. But if it's 1,000 times, and let's say probability is 1 over 6, that means 1 out of 6 of the times you would get a 1. So let's draw up a table, probability table. So we have our outcomes, which is going to be 1, 2, 3, 4, 5, 6. And we know that the probability of each is going to be 1 over 6, 1 over 6, 1 over 6, 1 over 6, and 1 over 6, and 1 over 6. So that means out of 1,000, 1/6 of 1,000 would be that, 1/6 of 1,000 would be that, 1/6 of 1,000 would be that, 1/6 of 1,000 would be that. In other words, I could take 1 out of 6 multiplied by 1,000, right? And plus it with 1 out of 6 multiplied by 1,000. But this time I would multiply it by 2 because it's that. Plus 1 out of 6, and I would multiply it by 1,000 times 3. Plus 1 out of 6 multiplied by 1,000 times 4. Plus 1 out of 6 times 1,000 times 5. Plus 1 out of 6 times 1,000 times 4 times 6. That'll cancel. So in each case, this one here is 1 out of 6. If we multiply these two together, this will be 1 out of 3. This becomes a half. If we multiply those together, this is going to be 2/3. This will be 5 out of 6, and this will be 1. And for each of these, we multiply it by 1,000. So let's grab a calculator, and we're adding these up. Okay, times in that by that. So now I'm going to grab a calculator, and on my calculator, I'm going to put that entire amounting. Maybe there are two different ways in which I wrote it there, at the bottom and at the top. So I got fraction button 1 over 6 multiplied by 1,000. Now it's approximate, right? So if it's decimals, it's okay. 1 over 3 multiplied by 2,000. All right. Oh, actually, times 1,000. And then multiplied by 1,000 plus 1 over 2 multiplied by 1,000 plus 2/3 multiplied by 1,000 plus 5/6 multiplied by 1,000 plus 1 times 1,000. And the approximate number comes to 3,500. And that would be the approximate score. Because a sixth of the time I would get each of those. So I got to take a sixth of the total throws, of the total amount, which is going to be, so if I took 1,000, for example, and I divided it by 6, I took 1,000 and divided by 6, because in each case here you can see I've just taken 1,000 and divided it by 6. So if I take 1,000, 1/6 1,000 divided by 6, and I just multiply it by 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4 plus 5 plus 6, I should get the same result. So it's going to be 3, 6, 10, 15, 21. So it'll be 1,000 times 21 over 6. 3,500. All right, so there's two possibilities of getting it. This one I factorized out that 1,000. That's when you have added it manually, done a table. This one I've done just looking at each component and adding it separately. This is known as the expected value of this event. All right, the expected value is whenever you take the probability and you multiply it by the total outcomes. All right, or by the observed outcomes. So in this case here, 2, we're going to get that 1/6 at a time. 3, we're going to get that. So we multiply each of those, and when we add it up, we get what is known as the expected value. It's almost like the average score that you would get for that period. For that. Okay.